Hey guys, in this video we're going to cover section 5.1, and this is going to talk about two different bisectors and triangles. One being angle bisectors, the other being perpendicular bisectors. Now, this is already vocabulary you guys are familiar with, but we have a couple theorems that we haven't talked about that do go along with these within a triangle, okay? So go ahead and take a second if you need to review these. We are going to be revisiting some of these things that we've already learned in previous modules, but they're there for you just as a refresher. Here's the new piece, the perpendicular bisector theorem. So if a point lies on the perpendicular bisector of a segment, that means it's the same distance away from the endpoints of the segment. So in this picture, if x is on the perpendicular bisector of AB, then x is the same distance away from A as it is from B. So that's the conclusion. Okay, so if we use that theorem here, so I know W is on the perpendicular bisector. How do I know that? Well, the 90-degree angle tells me it's perpendicular, and the tick marks let me know that it's bisecting, right? It's cutting it into two equal halves. So any point on this line is the same distance away from x as it is from y. So W right now is 7.3 away from x. So WY is also 7.3 away from Y. Okay, converse is if a point is perpendicular. Okay, sorry, what do I want to say? Oh, sorry, that's going to be our conclusion. If a point is equidistant from the endpoints, so another way to think about that is if it's the midpoint, or I know it's the same distance away, then XY is perpendicular to AB and YA is congruent to YB. So if I saw this picture and I know those two distances are equal, then this has to be the perpendicular bisector. So it's just the converse of that previous theorem. Okay, so here it says find BC. So these two distances are the same. So actually I didn't even need that right angle, but I know that it is perpendicular because those two distances are the same. And then that also means that this segment BC is being bisected. So if this length is 16, this one is also 16, and then BC is the whole thing. So 16 plus 16 is 32. Okay, all right, so now a theorem involving angle bisectors, okay? So if a point is on the bisector of an angle, then it's equidistant from the sides of the angle. So in this picture, I know this is an angle bisector because of those markings on the angle telling me they're congruent on either side. So if C is on this angle bisector, then C is the same distance away from PA and the same distance away from PB. So those two segments are congruent. Okay, so using that theorem, okay, this is an angle bisector, so M is on that angle bisector, meaning it's the same distance away from this side as it is from this side. So MJ is the same as ML, so ML or LM must also be 12.8. Okay, just like the perpendicular bisector theorem, we have its converse. Okay, so if a point is in the interior of an angle and it's equidistant from the two sides, then it's on the angle bisector. So in this case, then angle APC is congruent to angle, oh, I'm missing my angle somewhat, BPC. Okay, so then this angle is congruent to this angle. It's on the angle bisector. Okay, so they're telling me to find measure of angle ABD given that ABC is 112. So this whole thing is 112. Well, because these distances are the same, then I know that D is on the angle bisector. So to find ABD, I just have to do 112 divided by 2, which is 56. Okay. All right, so now we're going to refer back to those formulas from our earlier modules. We just wrote them on the previous page, so look back if you need to. So it says write an equation in point slope form for the perpendicular bisector of AB. So here's AB, so I need the equation of the line that's perpendicular to this one and it bisects. So here's kind of a key with bisecting, you guys. In order for it to bisect this particular segment, it must go through the midpoint. So the two things I'm going to find here are I'm going to find the slope of AB, and I'm going to find the midpoint. Here, I'll give myself some space here. The midpoint of AB, because that's going to be the point that does bisect that segment. Okay, so the numbers on here are kind of funky, you guys. So A has the ordered pair. You can see here's -1. Okay, so it's at -1, 4, 5, 6. So -1, 6 is where A is. Here I'm at 3, 4 for B. So those are my coordinates of A and B. Okay, so for the slope, y2 minus y1, remember it doesn't matter which direction you go as long as you go the same way. So I'm going to do B minus A. So I'm going to do 4 minus 6, y minus y, over 3 minus -1, x minus x. Okay, 4 minus 6 is -2, 3 minus -1 turns into 3 plus 1, which is 4. So -2/4, I can simplify that to -1/2. Okay, and I'm actually going to move this down a hair more too. Okay, so I don't want the slope of AB necessarily. I want to write the equation of the perpendicular bisector. So I need the slope that would be perpendicular to this one. So we wrote the rule on the front page here, but I'm going to use the upside down T perpendicular sign. If AB has a slope of -1/2, the perpendicular slope is its opposite reciprocal, which would be positive 2/1 or just 2. Okay? All right, so we have the slope we need of the perpendicular bisector. Now I need the point it has to go through, which is going to be that midpoint. So I'm going to use the midpoint formula, which is x plus x, so -1 plus 3 divided by 2, and y plus y divided by 2, and then simplify. So -1 plus 3 is 2, 2 divided by 2 is 1, 6 plus 4 is 10, divided by 2 is 5. Okay, so 1, 5 is the midpoint. Okay, so we can see here it's got to be here, and then it needs to be perpendicular. So I'm going to actually count. So here's the slope 1, 2, and over 1. So it's got to go through. It might not necessarily go through C. It can. Mine maybe does. Okay, but it's got to have that slope of 2/1, and then going through the point 1, 5. Okay, so the equation for that line, they wanted it in point slope form. So that's y minus y1. So here's my x1, y1 that I'm going to use, and here's the slope I'm going to use. Okay, so y minus 5 equals a slope x minus x1. And that is point slope form. I don't have to go any further. We are going to do the same thing one more time. Okay, so it says given A is at -5, 4. I'm going to kind of write these on here. B is at 1, -2. Okay, and X is at 1, 4. So they want me again to write the perpendicular bisector equation for, in this picture, it's going to be XY. Okay, all right, so I still need the same things. I need the slope of this line, and I need the coordinates of y, okay? Actually, I don't here. I'm going to do one less step. So here's what I need. I know x is on the perpendicular bisector, so I know that's my x1, y1 I got to use in point slope form. But I need the slope of xy. I don't have that. And I can't find it without knowing y, but I could find the slope of AB and then do the opposite reciprocal. And that's just one step. I don't have to find the midpoint in this one. I can just use x, but I do need to find the perpendicular slope. So let's find the slope of AB again. Okay, so y2 minus y1 over x2 minus x1. Simplify. 4 plus 2 is 6. -5 minus 1 is -6. So our slope is -1. Opposite reciprocal is +1. Okay, so perpendicular slope is +1. The point I need it to go through is 1, 4. So that's my x1, y1. Point slope form, y minus y1 equals our slope times x minus x1. So that one was a little quicker because we didn't necessarily have to find the midpoint. We had the coordinates of a point already on the perpendicular bisector. All right, guys, that is it for 5.1.